Chernigov Bridge collapse. On July 20, 2009, a heavily overloaded cargo truck attempted to cross the aging Chernigov Road Bridge in northern Ukraine. The bridge, already weakened by years of corrosion and deferred maintenance, buckled under the excessive weight. Within seconds, a large section of the deck snapped and plunged into the Strzezian River below, all caught on security cameras that later made global headlines. Miraculously, only a few minor injuries were reported, but the collapse exposed deep flaws in Ukraine's infrastructure oversight. Engineers found widespread metal fatigue and evidence that weight limit violations had become common. The government launched an emergency review of hundreds of bridges nationwide, many of which were discovered to be in similar condition. Economic losses totaled several $million, driven by reconstruction and regional traffic disruptions. The Chernigov Bridge failure remains a sobering reminder that even routine overloading, not dramatic storms or earthquakes, can bring down major structures. Hince Ribeiro Bridge collapse. On March 4, 2001, the 116-year-old Hince Ribeiro Bridge over the Douro River collapsed during a heavy flood. A bus and 3 cars were crossing when a central pillar failed, sending all vehicles into the raging water. 59 people were killed, making it one of Portugal's worst engineering tragedies. Investigations revealed that the river had been drenched frequently, scarring away sediment that supported the bridge's foundations. Combined with decades of inadequate inspections, the structure had become dangerously unstable. Despite residents repeatedly warning authorities about visible cracks, no repairs were made. The disaster triggered national outrage, prompting Portugal to overhaul its bridge monitoring systems and increase funding for aging infrastructure. It also reshaped European engineering policy around the hidden dangers of foundation scour, a silent but deadly enemy for older bridges. Polcevera Viaduct. For over 50 years, Genoa's Polcevera Viaduct, also known as the Morandi Bridge, symbolized Italy's modern engineering. But on August 14, 2018, during a storm, a 210-meter span suddenly collapsed, sending vehicles plunging 45 meters to the ground. 43 people were killed and dozens more were injured. Investigations traced the collapse to a combination of corrosion, aging pre-stressed cables, and insufficient maintenance. The original 1960s design relied heavily on concrete-encased steel cables that were nearly impossible to inspect, a flaw that had worried engineers for decades. Internal documents later revealed mismanagement and neglected repairs. The disaster forced Italy to confront a nationwide infrastructure crisis and sparked new European regulations on maintenance transparency. The viaduct's fall became one of the most publicized engineering failures of the 21st century, forever altering public trust in modern bridge design. Songsu Bridge collapse. On October 21, 1994, during the morning rush hour, a 48-meter section of Seoul's Songsu Bridge suddenly gave way. Cars and a bus plunged into the Han River below, killing 32 people and injuring dozens. The collapse shocked the nation, rapidly industrializing and relying heavily on new infrastructure. Investigators discovered severe welding defects, poor quality steel, and shortcuts taken during construction. Even more alarming, engineers found the bridge had been carrying far more traffic than originally intended. Years of fatigue stress compounded the flawed welds until the structure finally failed. The collapse became a turning point in South Korea's infrastructure policy. It led to sweeping reforms in construction oversight, stricter licensing for engineering firms, and a nationwide inspection program that continues today. Ponte de la Torre collapse. In October 2016, the historic Ponte de la Torre in Spoleto, a medieval aqueduct bridge dating back to the 13th century, partially collapsed following a series of earthquakes in central Italy. The bridge, long admired for its architectural beauty, lost several sections of its walkway. Although there were no casualties, the collapse symbolized the vulnerability of cultural heritage structures to natural forces and long-term neglect. Engineers found that centuries of weathering had weakened the stonework, and previous restoration attempts were inconsistent. The event fueled debates across Europe about protecting ancient infrastructure in seismic zones. It also spurred Italy to invest in monitoring technologies for historical sites, blending modern engineering with architectural preservation. Minneapolis Stone Arch Bridge Incident. In 1904, Minneapolis Stone Arch Bridge, an early icon of American railway engineering, suffered a partial structural failure when several limestone blocks along the rail line gave way. Although the collapse was small compared to later disasters, it halted rail traffic and exposed major maintenance flaws. Engineers discovered the bridge suffered from material fatigue and inadequate support for increasing train loads. At a time when railway transport was booming, the failure provided one of the earliest case studies of how aging infrastructure can buckle under modern demands. The incident led to extensive reinforcement of the Stone Arch Bridge and helped shape early American bridge safety standards, marking a key moment in the development of structural engineering. Yacht Regency Walkway Collapse. On July 17, 1981, during a crowded tea dance at the Yacht Regency Hotel in Kansas City, two suspended walkways collapsed onto the dance floor below. 114 people were killed and over 200 injured, still the deadliest accidental structural failure in U.S. history. The disaster stemmed from a fatal design change. Contractor modifications to the hanger rods doubled the load on the upper walkway connections. The connections failed instantly under the weight of dozens of spectators. The tragedy transformed engineering ethics and regulation. The US adopted stricter certification standards, peer review requirements, and rules against unauthorized design changes. The yacht collapse remains one of the most studied failures in engineering education. I-35W Mississippi River Bridge Collapse. On August 1, 2007, during evening rush hour, Minneapolis I-35W highway bridge suddenly collapsed into the Mississippi River. 13 people died and 145 were injured. The collapse shocked the nation. This was a major interstate bridge, not an overlooked rural span. Investigators found that undersized gusset plates, crucial steel connectors, had been part of the original design flaw dating back to the 1960s. Additional construction materials stored on the bridge added excessive weight, pushing the flawed plates to their breaking point. The failure triggered a massive nationwide bridge audit, resulting in repairs, replacements, and billions of dollars in federal infrastructure investment. It remains a critical example of how small design errors can lead to catastrophic consequences decades later. Sunshine Skyway Bridge Disaster. On May 9, 1980, during a violent storm, the freighter Summit Venture veered off course and struck a support pier of the Sunshine Skyway Bridge in Tampa Bay. A large section collapsed, sending vehicles, including a Greyhound bus, plunging into the water. 35 people were killed. The accident exposed major vulnerabilities in bridge protection systems. The replacement bridge, completed in 1987, was redesigned with massive concrete barriers known as dolphins to deflect ships. This is now a standard safety feature worldwide. The disaster reshaped maritime bridge engineering and remains one of Florida's darkest moments on record. Silver Bridge Collapse. On December 15, 1967, the Silver Bridge connecting Ohio and West Virginia collapsed during rush hour traffic. 46 people were killed as cars plunged into the icy Ohio River. The cause was traced to a single failed I-bar, a critical tension component that fractured from stress corrosion and microscopic cracks. The collapse exposed how catastrophic failures can stem from a single point of weakness. It led to the birth of the National Bridge Inspection Standards, or NBIS, requiring regular mandatory inspections for all U.S. bridges. Silver Bridge became one of the most influential engineering failures in modern history. Its lessons still shape infrastructure policy today. Tacoma Narrows Bridge Collapse. On November 7, 1940, the Tacoma Narrows Bridge, nicknamed Galloping Gertie, twisted violently in the wind before collapsing spectacularly into Puget Sound. The deck oscillated in dramatic waves due to aeroelastic flutter, a phenomenon poorly understood at the time. No one died except a single dog, but the collapse revolutionized bridge aerodynamics and wind tunnel testing. Engineers began evaluating how structures interact with airflow, leading to safer and more stable, long-span bridges worldwide. The footage of Gertie's collapse remains one of the most famous engineering videos ever recorded. Quebec Bridge Collapse. On August 29, 1907, the nearly completed Quebec Bridge, designed to be the world's longest cantilever span, collapsed catastrophically into the St. Lawrence River. The project had been plagued by rushed deadlines, underestimated steel weight, and ignored warnings from engineers who noticed the bridge's beams visibly deforming in the weeks before the collapse. At 5:37 p.m., with dozens of workers still on the structure, the bridge suddenly buckled. More than 19,000 tons of steel twisted and plunged 100 150 feet into the river below. 75 workers were killed, making it the deadliest bridge construction disaster in history. The roar of the collapse was heard miles away, and rescue attempts were hampered by the massive tangled wreckage. Investigations exposed fatal miscalculations in load assumptions and flaws in both design oversight and quality control. The tragedy triggered a complete overhaul of North American engineering practices, leading to stricter safety codes, peer review requirements, and more rigorous structural analysis methods. A second attempt to complete the bridge also suffered a collapse in 1916, killing 13 more, cementing the Quebec Bridge as one of the most infamous cautionary tales in engineering history.